This worksheet consists of 5 questions, and then all the 5 questions are based on the tension force. Now let us start working on these small questions. So first question is, a block is lying on a table, and then some tension, or somebody is pulling the block with 50 Newton force, and then coefficient of friction between the block and the surface on which the block is lying is 0.3. Now we have to find out F net of the system, acceleration of the system, and then the tension. Now for this I have drawn the free body diagram. So Fg is acting vertically downwards, Fn upwards, and then tension towards right, and then friction towards left, because the object is moving towards right. Now, coefficient of friction is 0.3. Let us write the y-dimension forces. Sigma Fi is equal to Fn minus Fg is equal to MAy. As the object is not moving along the y direction, so acceleration along the y direction is equal to 0. Therefore, Fn is equal to Fg. We know Fg is equal to mg. Therefore, Fn is equal to mg. And then substituting the values for m is equal to 5.5 and g is equal to 9.8, we get 53.9 newtons as the normal force. We know friction is equal to mu Fn. And then substituting these values, we will get friction is equal to 16.17 newtons. Please check the calculations with your calculators before submitting. Suppose if this, some of you may be taking this as the homework help and then submitting as it is. Sometimes I may go wrong when using the calculator. So please check with the calculator and then submit the assignments. Next, sigma fx is equal to, now we will write the x dimension forces. Sigma fx is equal to ft. I am taking the right side as the positive. This is positive x direction. This is negative x direction. Therefore, ft minus F friction is equal to MA. Therefore, F tension is given as 50. 50 minus friction is 16.17, just now we calculated, is equal to mass is 5.5 kilograms times A. From this, we can calculate A is equal to 6.15 meters per second square. So the answers for these questions are F net is 33.83 newtons or 34 newtons, and then the acceleration of the system is 6.15 meters per second square, and the tension in the string is 50 newtons. This is the first bit. Now moving on to the second bit. Second bit, the two masses are lying on a frictionless surface, and then both are connected by a cable, and then the cable has a tension T1, and then another cable has the tension T2. Okay. Now we have to calculate the values. Let us write the net force. Here, 50 newtons is the force acting on the system. So F net is the 50 newtons. And then sigma F is equal to MA. Therefore, this 50 newtons is equal to this string, this rope or this cable is pulling both the blocks. Therefore, sigma F is equal to MA. Therefore, 50 is equal to total mass, 15.5 kilograms times A. Our acceleration is equal to 3.23 meters per second square. This is the answer for the second question. Now, third question. Here, one object is lying on a table, another object is hanging, and then both the objects are connected by a cable. The cable is passing through the pulley. We are considering the pulley as the massless and frictionless. And then the first block, which is lying on the table, has the friction between this mass and the surface is the coefficient of friction between the mass and the surface on which the mass is lying is 0.3. Now let us consider M1 is equal to 5.5 kilograms and M2 is equal to 10 kilograms. Now let us write the force equation. This here is the free body diagram for both the masses. Here when we take the second mass, that means the 10 kilogram mass, F tension acts upwards and Fg acts downwards. And then for the 5.5 kilogram mass, F tension is acting towards right, and then F friction is acting towards left. So these are the X dimension forces. And then Y dimension forces, Fn acts upwards and Fg acts downwards. Okay, now this is the free body diagram. From this free body diagram, you can visualize everything. Let us write the force equation. Let us write the force equation for M2, the second mass, the mass whose mass is 10 kilograms. So for M2 is equal to 10 kilograms. So see, what are the forces acting here? Sigma Fi is equal to Fg. Here, this mass is more than the tension of Fg. So the weight of the 10 kilogram mass is greater than the tension. So I am writing Fg minus Ft is equal to M2A. This is M2A. So F tension is equal to Fg plus Fg plus M2A. No, F tension is equal to Fg minus M2A. Fg minus M2A. So Ft is equal to 98 minus 10A. Now we will write the force equation for M1. So for this, sigma Fx is equal to F tension minus F friction is equal to M1A. And then bidimensional forces sigma Fi is equal to Fn minus Fg is equal to M1A. Okay, and the object is not moving along the y direction, therefore Ay acceleration is equal to 0, and Fn minus Fg is equal to 0, or Fn is equal to Fg, or Fn is equal to, we will calculate Mg. Mg is 5.5 times 9.8, which is 53.9. We know friction is equal to mu Fn. Mu is given as 0.3 for us, therefore 0.3 times 53.9 is equal to 16.17 newtons. Now substitute the friction in the x-dimensional equation. So 98, F tension is 98 minus 10A. I am taking this one. F tension is equal to 98 minus 10A. And then minus friction 16.17 is equal to M1A. M1A is 5.5 times CA. And then solving the equation, we get acceleration is equal to 5.28 meters per second squared. This is the answer for this question. Now take the fourth bit. Here, two objects are connected by a cable and both are lying on a surface, and the uh, coefficient of friction between the surface and the masses is 0.2. Here, this is the free body diagram, and then the forces are represented here. Let us consider M1 be 5.5 kilograms. For this mass, the forces are y-dimensional forces are Fn and Fg. Fn acts upwards and Fg downwards. And then the x-dimensional forces are Ft1 acts down left side and Ft1 acts towards right. Okay. Let us consider, or we will not consider anything, just we leave it like this. This mass and is connected to another mass. We will see how the tension is acting. Now take the second mass. For this, the 50 Newton tension is acting towards right. It is given in the question itself. And then Fn and Fg are acting vertically up and down. Fn is upwards and Fg is downwards. Now let us write the force equation for both the masses. So for the first mass, for the 5.5 kilogram mass, let us write Fi. Fi is equal to Fn minus Fg is equal to May, and Ay is equal to 0. Therefore, Fn minus Fg is equal to 0, or Fn is equal to Fg. So friction is equal to mu Fn. Therefore, friction is equal to mu is given as 0.2. That means the coefficient of friction between the object and the surface as 0.2. And then plugging in the values for mu, mg, we get friction 1 is equal to 10.78 newtons. That means the friction between the first mass and the surface is 10.78 newtons. Now let us consider the friction between the second mass and the surface. Here again friction is equal to mu Fn. Here we will take the mass as 10 kilograms and calculate the friction to as friction between the second mass and the surface as 19.6 newtons. Now let us write the force equation. Net force sigma fx is equal to, here F tension is acting left and F tension 3 is acting towards right. In between the friction is acting. So Ft1 minus F friction 1 minus F friction 2 minus Ft3 is equal to Ma. And because the object moves left side. Okay, because this is 100 newtons and this is 50 newtons, obviously the object moves towards left. Therefore, friction and the F tension 3 must be subtracted from the F tension 1. Therefore, 100 minus F friction 1 is 10.78 and F friction 2 is 19.6, and then F tension 3 is 50 newtons. So solving this for, and that this must be equal to M total. So both the masses are moving, no? Therefore, we have to take the M total. M total is 15.5 kilograms times and then A, acceleration A. From this, we will calculate the acceleration A is equal to 1.266 meters per second squared. Now to find Ft2, let us, now the object moves towards left. So Ft2 minus F friction 2 minus Ft3 is equal to M2A. The object is moving towards left now. So Ft2 minus the F friction 2 is 19.6 and Ft3 is 50 is equal to mass M2 10 kilograms times acceleration is 1.266. Therefore, Ft2 is equal to 82.26 newtons. Okay, this is the answer for the fourth bit. Now, fifth bit. This is the Atwood machine. Two masses, if 5.5 kilograms and 10 kilograms are connected by a cable, and then the cable passes through the pulley. We are considering pulley as the frictionless and massless. We are not considering the mass of the pulley and the friction between the cable and the pulley. We are neglecting those two and then finding out the acceleration and tension. Let us consider the 5.5 kg mass as M1 and 10 kg mass as M2. So for 5.5 kg mass, we will write the force equation. Sigma Fi is equal to Ft minus Fg is equal to M1A because the weight is less than the tension. This is a 5.5 kilogram mass now, and then 10 kilogram mass is hanging other side. So the 10 kilogram mass is pulling the 5.5 kilogram mass. Therefore, Ft minus Fg is equal to M1A. And then from this, we can calculate Ft and plug in the values. And then from this, you will get Ft minus Fg is equal to M1A. No? So plug in the values and you will get the equation. Now we will move on to the second mass. Second mass is the 10 kilogram mass. For that, again, we will write the forces. Sigma Fi is equal to here, Fg minus Ft is equal to M2A because Fg is acting downwards and Ft is acting upwards. And then the weight of the object is greater than the tension. So Fg minus Ft is equal to M2A. Now plug in the values. Here, instead of Ft, you have to substitute the value from here. Ft is equal to here 53.9 plus 5.5A. This you have to substitute here. And the entire thing is you have to subtract from 98. Okay. Ft means entire thing. Now that is equal, and then solving this, you will get A is equal to acceleration is equal to 2.84 meters per second square. And then substituting this acceleration in this, you will get a tension as 69.54 newtons. So this is the answer for the fifth bit. Okay. So this, I hope this helps. Thank you. Bye-bye.